Hello everyone, Mr. Hissner here, and welcome back to just your favorite thing to do right now. Remember you were like, oh, can't wait for algebra to come back. Yeah, it's here. Okay, so let's look today. Today we're going to dive a little bit deeper into the idea of similar triangles and use our scale factor specifically for more triangles. So let us look here. So I have that these two triangles are similar. So we have two triangles here that are similar. That's what that tilde means without the equal sign. And what that means is that we have three angles. We have all three of our angles, and they're congruent. All three of the angles are congruent. But clearly, right, these triangles aren't congruent. The one triangle on the left, ABC, is clearly smaller than the triangle on the right. So while the triangles are not congruent, they have congruent angles, but not sides. And in fact, what we see is that all three angles of similar triangles must be congruent. And so, while they're not congruent, they still have corresponding sides, which is what we saw last time. So, you can even think of this as like 1, 2, 3, 1, 2, 3, and really it's just very simple to identify them. 1, 2, this one, 2, 3, that one, and then my remaining side is 3, 1 or 1, 3. So what can we do here? Well, we know there's some value, I'm just going to call k, that we can multiply x by times k, and it will equal y, right? K is our scale factor, so there's some number we can multiply x by to get to y. The reason why is because these two triangles are similar, and the two side lengths are proportional. So we got that going. Okay, so let's look. Let's look at what one of these examples looks like. Good old fashioned. So what do we want to find? We want to find GH. So first let me look at this. So that's GH. So that's these two. And then we want EF. So that's going to be an FD there because these are the corresponding sides. And so we need to find some number that's going to turn 12 into x. Now first, let me just look at the difference between these two sides. DF is clearly smaller. So if I want to make the number 12 into a larger number, I'm going to have to find a fraction to do so that's greater than 1. Why is that important? Well, because I want to make a ratio. I want to make a scale factor. And I really have to use this. This is my only option, is this triangle. This is JH. So I got to use DE. And remember, I want to go this way. Well, actually, I want to go this way. So I want to make 14 larger, and I want to use it, and I want to use a scale factor that's going to do that. So I need 14 times some number, and so let me think of the scale factor here. Scale factor is a ratio between corresponding sides, and so that's 15 over 9. And again, I'm using the bigger number on top. Why? Because I need the number to be bigger, because it's getting bigger. So it needs to be greater than 1. So this is going to be 5 thirds. So I just do 14 times 5 thirds. 14 times 5 thirds. 5 thirds. Oh, I don't know. I'm going to have to cheat. Is the other one easier? Oh, the other one's easier. Let me do DF first. So DF is going to be 12 times 5 thirds. This is much easier. So this is going to be 20. This one's a weird one. 28. So I got a 2, a 7, and a 5. 270 divided by 3? divided by 3? Whatever that is. I can't do that one in my head. Oh wait, yes I can. $23.3. Got it. Okay. So decimals are back on the table, guys. Sorry. What did I do here? I realized that I needed to make the numbers bigger, right? So y, this was y. and this is x. So I needed to use my scale factor to do so. That meant that I had to use the number greater than 1. So I chose 5/3. If I wanted to go the other way, if I wanted to make the number smaller, I could use 3/5. Both of these are the scale factors. Okay, let's see. A scale factor here. So let's see. We have TL, and CH. So let's just see what the scale factor is. Oh, you know what? This one, we're going to have to set up a proportion. Otherwise, we're probably going to end up wasting our time. So here we go. I'm going to set up a proportion. This is LY and KH or HK. So I'm going to set up a proportion with the corresponding sides. And I'm going to use those ratios. So my proportion is going to look like 10/25. Those are my corresponding sides. You know what? I'm actually going to use this one. Makes it pop a little bit more. So 10/25, and then 10 and x plus 5 are corresponding, right? They're on the same triangle, and 25 and 4x are on the same triangle. But first what I'm going to do is I'm going to take care of this fraction. 10/25 is actually 2/5. X plus 5, 4x minus 1, and then I'm just going to do some cross multiplication. This is going to be 8x minus 2. And then what am I going to do here? Well, I'm just going to balance this equation. Minus 5x from both sides. These two cancel. And then I'm going to add 2 to both sides. These two cancel. And so I'm left with 27 is equal to 3x. So x is equal to 9. So what do I do here? Well, I realize that, for these ones that are just numbers, we can use a scale factor. But when we get into stuff that starts to use algebra, we have to think, how can we use a scale factor? How could we use, so this is our scale factor, 2/5. But we need to set up some sort of a proportion. We need to use more than just a ratio. We need to use an equality. We need to use 2 ratios. We need to use a proportion. And so what am I doing here? Well, I'm just taking corresponding sides and making a ratio, corresponding sides and making a ratio. Now notice that 10 and 5x go together, 10 and x plus 5 go together, and 25 and 4x minus 1 go together, and also these two go together. So I'm really matching up. I'm using the corresponding sides. I'm just putting the things together. Really not that much of a process to do. However, what this is requiring you to do is to sort of understand what you're doing, to really understand what it means for parts to be corresponding, which maybe you don't yet. And if you do, this is probably super easy. Really, if you can match corresponding parts and set up an equation, a ratio, proportions, there's really nothing to this. Thanks for watching, guys.